Okay, we've got binomial question number 2. So here it is. We've got a footballer and he's playing crossbar challenge, and the probability that he hits a crossbar is 0.6. Now he's taking these shots 20 at a time. Okay, so 20 shots all at once, and yeah, hopefully he does well. Now, here's a couple of questions. Find the probability that he hits the crossbar with at least half of his shots. So have a look through there, jot some of these down, and we'll go through the answers in a couple of seconds. Rightio, it is answer time. So let's get going. Now, first thing you should have all realized is we need to model this on a binomial distribution. So let's say x here represents him, hitting the crossbar out of 20 shots. So we can say that's binomially distributed. You've got your 20 shots and the probability hits the crossbar is 0.6. So there we've got our distribution. So now what do we need to find? Well, we need to find the probability that he hits the crossbar with at least half of his shots. So be careful with the wording there. At least half. Now, if he's taking 20, what does that mean? We're looking for the probability that he hits, well, more than or inclusive of 10. Okay? So more than or equal to 10 times. That's what we need to find. Now, how are we going to find that? Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, etc. all the way up to 20. Now that's all the times he could hit the crossbar, right? So out of these 20 times that he shoots at the crossbar, he could hit 0 times. He could hit it once, etc. Now what are we looking for? We're looking for him hitting 10 or more times. So that's all of that. That's what we want. So how are we going to get it? Well, hopefully you can see from the diagram that what we need to do is work out everything up to and including 9, and then just do 1 minus that. So we're looking for 1 minus the probability of everything up to and including 9. How can we get that? We can get it from our calculator. So we'll go to our distribution. We're going for the binomial CD, so cumulative, and we'll go for variable, and we're looking for 9. And then let's enter in n, this time is 20 because it's 20 shots. The probability is 0.6. There we go. And that's our probability. So we need to do 1 minus 0.127521. So let's quickly store that. And then we need to do 1 minus that answer there. And that comes out as 0.872 to 366. There we go. Okay, perfect. Number 1 done. Next then, we need to find the probability that he hits the crossbar exactly 3 times. So this time we're looking for the probability that x is equal to 3. Sorry. Now if it's equal to a value, what we're doing is we need to then use the binomial PD. Okay. Whenever it's greater than or less than or something like that, then you use binomial CD. Whereas if it's just one value that you're looking for, i.e. just 3, we need to use the binomial PD. Okay. So let's get that loaded. So we need to go to our distribution again. We're looking for the binomial PD, number 4. We'll go for variable, and we're looking for 3. Enter in the other info, so n here was 20, probability 0.6. And there we go, so very small number there. We've got 4.23 times 10 to the minus 5. Okay, and there we go. Next then, question C. He shoots 12 sets of 20 balls. Okay, cool. So he's done this 12 times. And what we need to do is find the probability that he hits the crossbar with more than half of his shots in 7 out of the 12 sets. Now, this is confusing. There's a lot of info. So we've got to take this all in. Now, first thing we need to realize is we've already worked out the probability that he hits with more than half of his shots, because we worked that out in part A. So that's over there. So I'm going to write this out now. So I'm going to say, well, he's doing something 12 times, and the probability of him hitting with more than half of his shots is 0.872. But this is like a new variable now. We can't say this is x anymore, because x represented him taking just those 20 shots. But now because he's doing it 12 times, what we're going to say is, maybe we'll call this y. I'm going to say y is binomially distributed by this now, because y is now going to represent him hitting the crossbar with more than half of his shots in 12 sets. So now what are we looking for? Well, we're looking for probability that he hits with more than half of his shots in 7 out of those 12 sets. So we're looking for the probability that y is exactly 7. So now our distribution has changed very slightly. So when we do go to the calculator, you need to be careful to actually change your numbers around. So we're looking for x is 7, so let's put that as 7. N this time is 12, and the probability is 0.872. And there we go, we've got 0.0104 to 3 sig figs. And so there it is. So, a couple more questions done there. Hopefully you're starting to get the hang of how to use a calculator to solve all these problems, because it's so important. So, more binomials coming your way. Stay tuned, and I'll catch you in one of those videos.